Hello everyone, welcome to the session. This side Priya Bhatia. And in this specific video, we will be discussing about the implementation of random forest. So I hope that before coming to this session, you already have watched my previous video where we have discussed about the internal mathematical intuition behind random forest. We have seen that, okay, it's just a combination of multiple decision trees working internally, and it's a part of a bagging technique or ensemble technique that we have. So let's try to focus on the implementation of this classifier, random forest or regressor, any one of them, depending upon what kind of data we are using. So for this implementation, I am using the similar file that I have worked upon in the previous sessions when I was showcasing you the implementation of decision trees, so that we can compare the results. We can see how the trees are looking like in terms of random forest versus the decision tree. Always remember the internal maths will remain the same, that Gini impurity or Gini index things and entropy part, information gain part, whatever things you learned till so far with respect to decision tree will be applicable here as well in order to create that decision trees itself. But it's just that here we will be having multiple decision trees with us. So let's get started. So now let's start working on the implementation part per se. I think you have already seen this file which I was working in the previous videos as well. So what we will do is we will first of all try to import that random forest classifier so that we can be able to get the predictions of the quality of the wine that we are working upon. So what we can do is we can say from sklearn dot, as it's a part of an ensemble technique. So what we will do in the ensemble itself, we can have this function called as random forest classifier. Right? So I'll call this function, right? Even you can refer the documentation for the same, where you can see it's a part available in the sklearn.ensemble. So what I have done is I have just imported that. Now, what is the next step? Next step is to create a classifier. So what I will do is rf, I will take it as that name, as a classifier name. So I will call this function random forest classifier. And after that, I'll just try to fit my data on the training set that we have. Not on the sampled part, I'm talking about the main data that we have. So if you remember, in our decision tree classifier itself, we have tried to divide our data into training and testing, if you remember that. So here you can see, right? So I am just training on the original data that we have, which is x train and y underscore train. And then we will see the metric also. So here, if you will be able to observe in this data, I have skipped that EDA part. So that is not there. So without doing any kind of a EDA, the kind of data that we have, I just want to showcase you that, how we will be able to implement the random forest and decision tree over on top of this. But definitely, if you will do the EDA and after that, the same thing you will do, you will get a better numbers in terms of the accuracy, in terms of the precision, recall, and so on. So let's try to first of all fit our model, right? This is how basically you can train your random forest classifier. Now, you know that by default, number of estimators or internally, the number of decision trees, if I ask you how many of them are working, it will be 100. Why? Because in the last session itself, I told you that the default value that we can see in the documentation itself, it is mentioned as 100, right? So if you want to lower it down, you can make it 5, 7, 10, depending upon the need. And in this video itself, I will show you the hyperparameter tuning as well, via which we will be able to get the better parameters which we can opt for in this specific algorithm. Even that same algorithm you can apply for other machine learning algorithms also in order to judge what is the best parameter for the available dataset that we have, right? Now training is done. Now let's say if I want to see the score of this data, this model on my test set. So what we will do is maybe we can just try to check it out, the scoring part, by mentioning what is our x underscore test and what is our y underscore test. So you can check out the score for the same. It is coming out to be 63.28%. Okay. So this function of score, you can, I think will be able to see in this again documentation itself, that how is this score is being generated. So you can just refer this part. Maybe let me just search for this score. If I'll just show you in this documentation, I think you will be able to get. Yeah. So here, can you see? So it returns the mean accuracy on the given test data and labels. So what you have to specify is what is the test set X value you have and the test set Y label you have. So in our case, it is X underscore test and Y underscore test. If you want to see the predictions of the model, so again, you have to say rf.predict. And here you can just refer X underscore test, and you can store these predictions in Y underscore predict underscore rf, because this is the kind of a predictions given by the, you can say, random forest classifier. So I can just print, right, what is the value of Y underscore predict underscore rf. And again, you can just check the values. It will be a quality of the Ys that we will be able to get from this part, right? So in this way, you will be able to see the complete end-to-end scores. If you want to check the estimators which are working internally, which is decision tree, so how can you check? There is a method called as estimators underscore. If I'll just showcase you, you will be able to see all the estimators which are working here. So here, if you will just see, there are multiple estimators we have, and you can see internally, this is the classifier which is working upon, which is decision tree classifier, right? Now, if I'll just go below, if I'll just have to showcase you that how the tree looks like with the help of that plot underscore tree function. So basically what I supposed to do, I'm just showcasing you. I have just increased the figure size to 20,20. For example, if I am saying that, try to showcase me the first decision tree that my model is having. So you will be able to see that, right? It will take some time, but at the end of the day, you will be having a decision tree available with you. Same sense, everything is same. It's just that now we will be having multiple estimators available with us. Again, whatever functions I'm using, for example, I have used just now the function of estimator. You can just check that out, right? So here you can clearly see what is the inference of this estimators, right? The child estimator template used to create the collection of fitted sub underscore estimators, right? So it is giving us a list of decision tree classifiers. That is what we will be able to get. So if I'll just go back, you will be able to see a complete end-to-end decision tree available with us. So now one interesting thing which you will be able to see here, if you want to just verify regarding the number of estimators which I just now showcased you, right? We can verify that as well, that whether it is actually 100 or not via some simple logic. It's a list, right? When we are trying to check it out, and we know that as per documentation it should be 100, right? But what I can do is I can maybe try to showcase you by storing it inside the list. LST is equals to, maybe we can store it here, and if I'll just try to showcase you the length of this specific list, you will be easily able to understand that it is 100. So always remember that this underscore estimators underscore will basically tries to give us all the decision trees that we have, right? Now, okay, this is the simplest implementation of random forest classifier. But if let's say in future you are trying to have a problem or a data set in which the regression task you have to perform. So the only difference is, instead of importing random forest classifier, what you will do is you will try to import another function by the name of random forest regressor. Okay? And whatever task we have done here, it's just that you have to perform with respect to the regressor function. We have a regressor and classifier depending upon what kind of task we are trying to solve. Things will remain same, functions will remain same, the way to implement the things will remain also same. Parameters are also same. The only difference is what we have discussed in our previous discussion of decision tree, the difference between the decision tree classifier versus decision tree regressor, right? Now, when we are talking about this random forest classifier, we have seen that there are multiple parameters we have. For example, number of estimators. Maybe as per my data, I'm not sure that whether the default number, which is 100, is fine or not. Or shall we try to increase this number or decrease this number? Similarly, the criteria, which is by default Gini, is that fine or entropy is a better measure? Similarly, the max underscore depth. Similarly, the min underscore samples underscore split. Meaning, I think now is the time where I should discuss about that how can we basically tune our hyperparameters. So that is where let's try to discuss about the hyperparameter tuning. So as per our given parameters, how can we tune these hyperparameters? See, there are two ways to tune that. One is something algorithm by the name of grid search CV. And another one is something which you will heard is as a randomized search CV. When we're talking about grid search CV, what will happen is you will try to give some specific numbers or range to the parameters. You will say to the model that try to explore all the possibilities and let me know whatever be the parameters best for my model. For example, I'll just showcase you one demonstration for the same. For example, here, let's say you will say grid underscore param. Maybe let's assume that I'm confused with few parameters and I'm just taking up few numbers here. You can just try to understand from this part. So here I'm saying maybe number of estimators 5 might be good in my data. I'm not sure. 10 might be good, 50 might be good, 100 might be good, 120 might be good, 150 might be good. So what I'm saying to my model that try to experiment with all these estimators and then let me know whatever with the number is best fit. Okay. So this is something we are trying to capture here. Similarly, for criteria, I'm highly confused that whether Gini is the best measure or entropy. Max depth, I'm saying try to explore from 0 to 9. Max min underscore samples underscore leaf, I am saying explore from 0 to 9. So this is the parameter which we are passing. Now what will happen is we will try to call our grid search function here. So you can see grid search CV is a method which we will call. Here I can showcase you in the documentation as well, which we are talking about. This is the name, grid search CV. So what it will do, it will exhaustively generate candidates from a grid of parameter values specified in this param underscore grid, which in our case I have specified inside the grid underscore param. Okay. Now this param underscore grid is this parameter which you have defined, right? CV belongs to the cross validation part, which I am saying for now is 10. Basically, it's again a hyperparameter tuning part only, where we are trying to split our data into training, testing, and validation. And depending upon the different sets which our model will be able to generate, we are saying 10 times repeat the same task and perform this specific tuning part. After that, you will see this estimator is nothing but our model name. So if you remember, the model name that we have defined for random forest is RF. So let's try to run this code. It might take some amount of time, right? But it will run. And after that, what we will do is we will try to fit this model on top of our training set. So what we will do, we will say, just try to work upon on the X train and Y underscore train. I'll showcase you in this demonstration itself the best parameters after the training is being done. So I'm just running this code. Okay, I think we need to import the method of grid search CV to implement that. Let me just open the documentation. So you can see it's under the model underscore selection part. So we can say one thing here, from model underscore selection. What we can do is we can just import a function name called as grid search CV. And I think now it should run perfectly fine. Let's see, model underscore selection, right? sklearn from sklearn dot model underscore selection. Let's wait for a while. Grid underscore param, they are saying, I think, okay. So the spelling mistake is there, PARAM. Let's try to run this again and let's wait for a while. Let's see what we are getting here. This cross validation part, I'll talk in the upcoming module where I'll discuss this in a detail, that how many types of cross validations we have and what is the significance of this particular part. But for now, you can consider that it's a part basically which is basically helping us to tune this hyperparameters itself. In the upcoming part of the course, you will see we have a separate module of hyperparameter tuning altogether, where I'll showcase you in depth regarding this cross validation part. So don't worry if you will not able to understand this part. Okay. Now you can see it is taking too much amount of time. One thing which you're supposed to do is, if you're doing with me, just try to change this runtime type to GPUs as well, so that at least the performance will be better as comparable to normal CPUs, which by default you will be having if you will not change it, right? Once this part is done, you will be able to see that after this, there is a method name called as best underscore params underscore. So in the meanwhile, let me just showcase you regarding this part, right? So you can see CV is nothing but it's of integer type. It's a cross validation generator. Determines the cross validation splitting strategy. We will talk about this part, right? How many strategies that we have, right? None to use, the default 5 is there. If you are specifying the number of folds in a stratified k fold, it's a part of a cross validation type. k-fold, stratified k-fold. Whenever we will be having imbalanced data, we definitely go for stratified. Otherwise, we'll go for a k-fold. Everything we'll discuss. Don't worry about this part, right? And one thing which I want to showcase you is this parameter, right? Best underscore params underscore. So you can see this parameter call, this particular method call will basically help us to provide us the parameters which is giving us the best result on the holdout data. Means whatever be the parameters you have specified in this dictionary, my model will try to give to me that, okay, with respect to this random forest, in this grid search CV which you have provided to us, the parameters that you have provided to us, this is something which works the best for your case, for your data set. So why it is taking too much time? Because internally now it's kind of a iteration which is going on, that for 5, what is the kind of a score we are getting? For 10, means our model is doing a lot of hard work. And higher this range, you can say higher the hard work, higher the time of training it is required. Yes, definitely, if you will be having a great GPUs available, or if you have taken a Collab Pro subscription. I remember when I was doing the research from my IIT Hyderabad in my master's program, I usually try to take a Collab Pro subscription. The advantage is that it usually gives us a better GPU platforms. Or if you are having a good computer, maybe by the company itself, or it's your own system, that is also a great thing. So if you have a good GPUs, automatically the training time will be less. But definitely if it is not the case, then if you're using normal CPUs, it will be more. If you're using an average kind of a GPUs, it will be lesser than that. But definitely if you're having a stronger GPUs with you, definitely the training time will be very, very less. Now let's wait for a while. Otherwise, if it will be too long, I might pause the video and then again come back with respect to the upcoming part. Let's try to work in the meanwhile with respect to the another part of hyperparameter, which I was talking about, which is the randomized parameter optimization. See, when we are talking about grid search CV, as I told you that we will try to provide these parameters, and it will try to explore all the possible parameters that we have, right? For example, it will go to Gini also, entropy also, and will check which particular criteria is giving us the best result. In the number of estimators, it will go to 5, 10, 50, 100, 120, 150, and will explore whatever values a user has been provided, which works the best for our model. But when we are talking about the second technique, which is a part of again hyperparameter tuning, which is the randomized parameter optimization, you can see what is happening is, as the name itself suggests, our model will randomly pick up some values. Okay, here user is not manually writing some values here, right? In the grid we are writing. So here you can see, while using a grid of parameter settings is currently the most widely used method for parameter optimization. Other search method which have more favorable properties is randomized search CV. So if I just try to open this documentation, one interesting thing which you will be able to observe, that out of grid search CV and randomized search CV, somehow grid search CV takes longer amount of time as comparable to randomized search CV, because here randomly exploration is going on there, manually user is writing, and it depends how many values they are writing, right? How much is the search space they are writing. So it really depends on that. So you will be able to observe that, randomized search CV somehow there are very less chances people are using. Grid search CV, many people are using because they know the probability that, okay, this is something which we required. So they're giving that, okay, these are the numbers, please look upon that thing, right? But anyhow, this is also, you should know, and it can be widely used at any point of time when you feel that the training time should be less and you want to do the hyperparameter tuning as well. It's a good approach, right? So here you can see it implements a fit and a score method. Here you can see again we will be having estimator, param underscore distributions, iteration, scoring, and so on. So if we can see the code for this also, I can just showcase you if I'm able to get that. So here you can see, right, they're trying to do on a model named logistic regression. I think we have already covered up this model, this particular algorithm. So what they have done is they have directly applied this randomized search CV, where they are internally calling this logistic. They're calling what kind of distribution it is forming, and it's a random state. I think if you'll not mention that, also it will work. So definitely you can see that in this implementation of randomized search CV, you can clearly observe we are not as such mentioning any specific parameters. We're just calling our function on top of whatever model we have trained on, just to get the better idea, better values. And again, what you have to do is you have to call that same method of best underscore params underscore, and you will be able to get the best parameters with respect to the logistic regression algorithm, right? So here, this is how basically the, you can say randomized search CV works. And this is the main difference between grid search CV and randomized search CV. Sometimes in an interview also, interviewer asks from you that what is the major difference between these two, and at what point of time we can go for which kind of tuning method, hyperparameter tuning method. So you should have a reasoning behind that. You should know the reason that, okay, this is where I should go for grid search CV, and this is where maybe I can go for the randomized search CV as well. Okay. Now, I think still it is, you can say it's being running, right? Maybe if you will be able to observe here, that I hope that this part is pretty much clear to everyone, that what are the things available in the randomized search CV versus the grid search CV. Your task after this session will get over is to, you have to try to apply the same thing on top of this RF estimator randomized search CV. So in this session, I have showcased you that how the grid search CV works, but you have to apply a randomized search CV on your own, because I have showcased you the implementation also in this page, right? You can just refer the documentation, and accordingly you can try to apply on this Vine data that we have on top of this random forest classifier that we have, right? Just now I have showcased you. Here they are trying to do it via logistic regression algorithm. On top of that, we want to do it on top of random forest algorithm. Maybe what I can do here, I'll just try to stop this, because it is taking too much time. Maybe I'll just give very few numbers here so that my search space will be less, and then maybe we can just try, because my goal is ultimately to showcase you how the things are working. So maybe I'll just remove this part also, right? So that I'll just showcase you the literal way of doing this. Might be this will impact and will be able to give us a faster result, because now I have reduced the search space of my model. It might take now lesser time as comparable to the previous code, but let's wait for a while and we'll see that what are the best parameters we will be able to get. And once we will be able to get that best parameters, we can able to see, although you can at your home try for all the parameters that we have, because you have a time, you can explore all the things, right? But for now, I'm just taking this much parameters only. One thing is that there should not be comma here. Let me just again stop it and rerun it again, right? Now it should be fine. So this is what it is. And then we will be able to get the best parameters. Once it is done, maybe as per those parameters only, I will try to apply the further random forest algorithm again, and we'll try to do the training again. So maybe let's wait for a while, and then again I'll come up once the code will run fine. I'm just pausing the video. I'll again come up when the code is executed properly. Okay. So now if you will be able to observe, my model runs perfectly fine. If I'll just try to showcase you now what is the best parameter my model is saying to me. So here it is saying criteria should be entropy. By default was Guinea, if you remember. Max depth should be 4 and number of estimators should be 120. So what we can do is we can try to recreate a new model now, RF underscore new. I'll try to call random forest classifier again, but now with the specific parameters. For example, we will say that the n underscore estimators value should be equals to 120. We will say the value of criteria should be equals to, I would say, entropy, because this is what our grid search CV told us. The value of max underscore depth should be equals to 4. I'll go with this and I'll try to fit my new model on top of this training data that we have, which is x underscore train, comma, y underscore train. Okay. Once it is done, what will happen is, let's try to first of all fit this. Perfect. Now you can again recheck the score just like the way we have done for the random forest. So we can just pass the x underscore test value and y underscore test value to check the new score value that we will be able to get. Now you can see it's 63.28, and what was the value we were getting previously? I don't exactly remember, but let me just go through that value also in the score part. Okay, here it is 70.69. Somehow it is quite bigger as comparable to the below one. The reason might be because we have taken a very low search space, right? So here At your end, what you can do is you can try to filter out all the available values in our random forest algorithm that we have. Definitely, I cannot showcase you by taking all the parameters in all the specific ranges. The reason would be because it will take too much time for training per se, and I'm recording the video. But I think I have made my point very clear that how basically you can do the implementation for this algorithm. That's the major objective to showcase you, right? So this is how basically the grid search CV algorithm works. This is how basically people try to find the better optimal parameters and they try to optimize their results. Always remember at any point of time, whenever you are feeling that you're not even sure which particular parameter might suit your data, go for this technique, and you will observe in practical real-time projects in the industries, people are using this technique quite frequently because they are exploring all the options, because they have access of resources as well. They don't have as such limitation. So they can use that and they're using that as a part of their code work, right? And you should also know about this technique, and definitely when you will go and work in the industry, or if you're working, you know that how much important it is, right? So now, as a task of today's session, as I told you, what you have to perform, you have to explore the implementation of a random search CV on top of the random forest algorithm. So you have to use the random forest algorithm as the base algorithm, and what you're supposed to do is you're supposed to implement the same. Okay, so this is something which is required at your end. Definitely, if you will see at the end of this course, we will be having a separate module of hyperparameter tuning, where definitely I'll try to take again one other data set and I'll try to showcase you everything from scratch. And there will be a concept of cross validation also, which I will discuss in depth in that session itself. So don't worry with respect to that part. But here I just want to showcase you in this part of the session that what is the meaning of hyperparameter tuning, how it is different. Maybe we have two types, how grid search CV is different from randomized search CV. How can we do the implementation for that? And now I think it would be pretty much clear to everyone that this specific technique of hyperparameter tuning is not only applicable for random forest. It is equally applicable for all the kind of algorithms that you have explored so far. Or in future also, whenever we will discuss about other algorithms. For example, in future you will see we are exploring SVM, KNN. We already have explored about logistic regression. Just now I have shown the documentation where in the documentation, they are applying a logistic regression on top of that randomized search CV to get the best parameters in logistic regression. So by saying that, this knowledge is not limited towards random forest algorithm. This knowledge is equally applicable for all the algorithms that we have in ML, wherever we want to find the best parameters, right? Either you're using a default one or you're finding a best one. So when you're finding a best one, you will always go for this hyperparameter tuning technique, right? So please try to explore whatever task I have given you. I think let's see how many of you will be able to give me an appropriate result. Try to read the documentation as well, side by side. Do your own research. Don't limit your knowledge with respect to whatever things I'm sharing here, because ML is a very vast domain. On a daily basis, you will observe documentations are keep on updating. Please refer that whenever you are studying these things. And whatever things I'm teaching you here, on top of this, keep on exploring your own research. Whatever doubts you have, please do reach out to me. And with this, I will see you all in the upcoming videos. I hope that you have enjoyed the course till so far and your learning journey is pretty much amazing.